mình đi học bên Đức thì học đầu tiên là mình học ở Chemnitz, Master School, sau đó chuyển sang TU ở Berlin.
Dạ.
Yeah, I would like to introduce some of you. This is Professor Duong, and today the chairman will be Dr. Sung Thang Wu. But before we start, because we still have 2 minutes more, so maybe we can talk and let's introduce each other.
Yes,
okay.
Great.
Yeah, very good.
Here we have a Mika Sri from Poland.
Hi.
Hi.
Great.
Hi.
Yeah. We have Mika Sri Associate Professor, right, Mika?
Yes.
Yeah.
It's great. Actually, we have. I just got information that between Germany and Poland, we have a collaboration program on I think high-tech issue. So for the cases you are interested into, I can send you the link. Maybe it's a good idea to discuss about the possible ideas. But you need the SMEs. So that's one requirement for the program, that you need the SMEs from both countries in order to submit.
Yeah.
I will wait.
Okay, right.
And we also have Quang, Hoàng Đức Quang. He's after many years in abroad, he came back Vietnam, and now he is lecturer in Tôn Đức Thắng University.
Yeah, I'm working in Tôn Thắng University now. That's starting about 4 years ago, and
okay,
and working with in south part of Vietnam. But actually, I'm from the north part of Vietnam, similar like Thai, and has current husband.
Yeah.
Okay, right.
And Wang and Nika, both of them work on high resolution theme, I think.
Yes.
Yeah.
Yeah.
And I am from Silesian University in Poland. Silesia is a south part of Poland, close connected to Germany, I think.
Yes, I think it's quite good idea for the cases in Berlin. So welcome to visit us here in Berlin. So
hello.
Hi, Chang.
Yeah, hi. Yeah.
How are you?
Yeah. And we also have Associate Professor Mai Hong Han from what is the name of the university?
Hanoi University
of Sciences.
From Hanoi University of Science. Hi everyone. So my name is Hạnh Mai. Hey, so I'm looking for this seminars because I heard about I heard about Dr. Ha for a long time. I also studied in Germany when I did my PhD.
Okay.
Yeah, in Kassel University. So
right, it's really good university.
I hope so. So well, I think it's at least that we have something in common. So anyways, it's very nice to see all of you.
Right, nice to see you too.
Yeah, we have Duy here. Duy is postdoc in France.
Yeah, hi everyone. Nice to meet everyone. I think I'm the youngest one here. I just started my research career in 4 years. I obtained my PhD degree last year, so I'm looking forward to hear something from everyone.
Yeah.
Okay.
Lương Viết Mùi. Lương Viết Mùi, he is assistant professor in Japan. Mùi, can you unmute and show yourself, please?
Hello, everyone. Sorry, it's not convenient for me to speak or talk, so I will mute myself and the camera as well.
Yeah.
But anyway, I will hear the presentation from Professor Ngô Hà Duong.
Right.
We also have Thanh Tuấn Bùi. I don't know if he's the new one, I think, and Viet Thanh Pham and some other ones. And I think there's some people, they will show up later. And we have Thanh Dao. He's a researcher in Austria. How are you?
Hello.
Hi,
hello, anh Dương.
Hi.
Actually, yeah, we often communicate this day with Professor Duong.
Yeah, I'm Thang Dao. I'm working at SAR as a staff scientist. Before moving to SAR, I worked at the National Institute for Material Science, NIMS, in Japan for 7.5 years. Nice to meet you here again.
Yeah. Okay. Thank. Do you think we should start now, or
with you, I think we can start shortly. Start with the introduction, and then Mr. Zeung or Dr. Professor Zeung can start with the presentations, and then people can join us later. Yeah.
Right.
Yeah. So good afternoon. My name is Sun Tang Wu, and I haven't had a short introduction before. So I'm a researcher at Aachen University, so adapted at Aachen University here in the west of Germany. And today I've been, have my honor to chair the talk of Mr. Zeung. He will, so if there's some, okay, yeah. So first of all, I would like to give a short introduction about his scientific or career. So Mr. Zeung first studied in Soviet Union in 1988 in electronics and aerospace engineering. After that, he came to Germany and studied at TU Chemnitz from 1993 to 1998 in about electrical engineering and microsystems engineering. And he continued his work here in Germany to do the PhD at TU Berlin. I think it's also one of the best universities in Germany. And he got his PhD title in 2006, where he worked about MES, micro mirror for telecommunications. After that, he worked as a technology manager at SCHOSS AG, SCHOSS companies on the topic CMOS camera technologies fabrication in Singapore. And since 2006 and to 2012, he is associate professor at TU Berlin. And after that, he got a full professorship in the University of Applied Sciences in Berlin, and also a group leader at Fraunhofer Institute IZM, and a lecturer at TU Berlin. So actually, you will see through his presentation today. Of course, he talked about research activity and funding, but he also talked about his research. And his research activity or his research interest is about MEMS, sensor, different kind of sensor packaging, and also sensor for solution for harsh environment. So, for example, like with a sensor that can work at a high temperature. Based on, for example, like graphene's silicon carbide based micro system. Yeah, so I think it's take quite long time for the introductions, since he have quite long CVs. Yes, so yeah, I think this is also now 6 minutes after 2. I think we can start with a presentation from Professor Zeung. So now the floor is yours.
Thank you, Tang, for the very nice introduction, and Gurm for the invitation. I think the network, the idea is really good to share and to discuss maybe about the new ideas, but also the how to get funding, because every one of us does have ideas, and you know that in research and industry, actually, we need money to realize our ideas, right? So it's quite important to know the funding schemes we have. So actually the system, the schemes differ a lot from country to country, but I mean the way and the method could be similar. Okay, so today I'm going to give some, I mean, my experiences on these issues, and also to give some right, to show you some activities we have here in Berlin in our institute. Maybe that we can find some ideas for collaboration in future. I don't know. Right, let's start. My idea is to first to start with our institute, with our organization, because actually here is an actual model we use here to get funding, right? So that actually the big idea, you know, that in European Union, actually you have collaboration between universities and research institutes, because the research institutes actually you have very good infrastructure, but the institutes do have very high overhead, right? So that for some research schemes is quite difficult to get funding as for our institute, okay? And at institute, you do not have enough people, manpower, right? So the manpower actually you find at universities, because you have students, you have PhD students, you have ideas there. But as a university, you do not have a good infrastructure. So the idea here is to combine the advantages of both structures from universities and from research institutes in order to get the eligibility for different funding schemes. This is the idea we have actually here in Germany. So you see many collaboration between Max Planck Institute and the universities over the countries in the main cities like Berlin, like Bayern, like Gießen, Dresden, and Leipzig, but also between Fraunhofer Institute and universities. So here in this case, we have a collaboration between TU Berlin, the University of Applied Sciences, and the Fraunhofer Institute IZM in the area of microelectronics. We are looking also for a new collaboration with Technical University in Cottbus. It's a small university in the east part of Germany. You know, the Berlin and the area Berlin and Brandenburg actually is quite weak, right? You have many structural changes in the region, and so especially for the weak regions in Berlin, we call it local government, we have a special funding scheme. So that's why the new collaboration with the university in Brandenburg actually is to get the funding there, right? And after that, I give some ideas how I have done here in my case, right? So maybe that's also some ideas for you, because in the European Union, actually the scheme, the funding schemes, actually quite right becoming similar. Okay, and then give some overview about my activities in sensors development in silicon carbide, in graphene. So for the cases we are working in the same direction like Tang. We have talked about CNT-based sensors, and with Tang from SAL, actually we have submitted recently one proposal in silicon carbide quantum platform. I hope that the platforms could be one solution for future quantum sensors. But okay, if you have any question, just stop me and ask your question. Okay, right. Okay, you see here the structure of our collaboration in Berlin. We have a TUB, we have a Fraunhofer IZM, we have a University of Applied Sciences. You know that the Fraunhofer Society is one of the biggest research institute in Germany. We have a Fraunhofer Society, and we have a Max Planck Society. Max Planck Society actually focusing on basic research, right? And Fraunhofer Society is focusing on how to transfer the research reasons from Max Planck into applications. So we are something like bridge between research and industry. Okay, and in Fraunhofer Society we have about 80 institutes located over whole country. We have in Berlin 7 big Fraunhofer institutes. in microelectronics, in telecommunications, in material research. And IZM is one institute belonging to the microelectronic cluster, and focusing on MEMS and microelectronics packages. So IZM is integration and reliability studies. Okay, so we are at the moment, we have about 400 people totally, but the numbers is changing very fast due to the corona crisis. We have lost many PhD students and also collaborators because the project ends and we do not have the chance to continue the research topics. We are in Berlin and also in Bavaria and in Dresden. The idea is quite simple. In Berlin, we have the flexibility to do the research and development. In Dresden, in Bavaria, we have the connections to industry, so that we do transfer in Bavaria and in Dresden, because in Dresden, you know, the new fabs, the global foundries, the Bosch, Infineon are producing there, so that we need connections to industry in order to transfer our research results into the production. Right, the 400 people are divided into 4 main departments. One, the wafer level system integration is the department focusing on semiconductor, on the front-end technology. So everything in silicon and on silicon we can do here in Berlin. We have one of the best research, so clean room infrastructures worldwide here. Actually, we have spent more than 100 millions into the clean room facilities. And the second one is system integration. It's the second, or we call it back-end offline technology. So everything ongoing at the panel, at the PCB surfaces in order to make the product, to make the systems, right? So we do in the second department. And we have 2 large departments on environmental and reliability studies. So it's quite simple, but very important, because actually, if you are going to produce something, so the customer actually asks you how long, what for lifetime the system or the products will have, right? So that here in this department, we deal with the question, sub-question, what for lifetime the products will have, and how reliable the solutions are. Okay. And also environmental, because in microelectronics, actually the technology is quite long and you are consuming a lot of energy. You have too many materials which might be not compatible or not suit the environmental requirements, right? So that for the future technologies, manufacturing processes, maybe we have to adjust, we have to use to develop new solutions, new materials, so that we can conform the requirements from EU. Actually, you have a very high requirements for the productions for manufacturing in the future. And in the last department, you see here RF and smart sensor systems. So here we deal with the questions like 5G, 6G, and how to make the sensor network. So you heard about 5G, 6G networks, and how the can say that the autonomous systems actually need the communications platform to communicate, to make the decision and so on. For automotive industry is actually quite important. Okay. Right, and in Dresden, you have 60 people in the center on silicon system integration. So here we work really on 300 millimeters wafers in order to produce the solutions for industry. Right, and you see here the idea behind it. So we need in universities, we need the institute in order to have eligibility to submit our ideas in all funding schemes, right? In Germany, actually, you have the funding schemes for industry, you have the funding schemes for research and large-scale institutes like Fraunhofer Society or Max Planck Society, And if our affiliation IZM can submit here our proposal, but also we have the universities in this collaboration in order to submit our ideas in federal funding schemes like EFG, so the German Research Foundations scheme. They are funding basic research, but also there's some local governments like Berlin, like Bavaria. They are funding also research activities from universities, from companies like SMEs, for example, very strong. They have 200 million euros budget to fund the activities in companies. So we can support the companies in such activities, but also to get part of the funding for us. Right? So this is the idea of the collaboration universities and large-scale institutes like Fraunhofer in our case. So actually, we have all the boundary conditions in order to work to have activities in all the funding schemes. This is very important. It's quite interesting, and you might be able to get enough funding in order to realize your ideas, right? And I have learned that do not focus just on the university, on the affiliation you actually have, but try to talk to extend, to have a network with other institutes and also companies in order to collaborate with them to get more funding. Right, here I have some information, some data about IZM. So founded in 1993 in Berlin. Actually, we had two professors here, pioneers in MEMS, in microelectronics packaging, Mr. Reichen and Mr. Obermeier. So both are really well-known scientists in Germany, and started MEMS activities in Germany. And you are located here in this building. So this is very old AEG complex. It's former AEG fabrication site here in Berlin. Have really good infrastructures. Focus on the competencies you see here, MEMS, Microsensors. So in my group, focus on wafer level system integration, so everything in silicon, and substrate technology, so everything on PCB, as mentioned before. We have also competencies in system design, so not only bottom up, but also top down approaches you can conduct here. Materials and reliabilities, as I mentioned before, is for industry is quite important. You want to know the lifetime and reliability of your products. And the last year is IoT. You notice the development of IoT-based system for autonomous systems is one of the key developments right now in European Union. Right here we see the advantage of institutes like Fraunhofer Society. You see here the two very big clean rooms we have here in Berlin and in Dresden. In Berlin, we have 800 square meters clean room. You have here different wafer sizes. This is the idea behind the flexibility we have in Berlin. We can work on different wafer sizes from 2, 5, 6, 8, and 10 zone wafers, so up to 300 millimeters. You have the chance to do here in Berlin. And in Dresden, you see here, because we have the transfer, the contact to industry, so that in Berlin, in Dresden, you have the clean room focusing only on two big wafer sizes, 200, 300 millimeters, because we work here very closely together with Bosch, with Global Foundries and Infineon. So key players in sensors production, they produce only on large scale wafers, so 200, 300, and 450 millimeters, so that you need the same wafer sizes in order to work with them. Okay, and here you see the technologies you have. Actually, we cover the whole value chains from thermal oxidation, so front-end applied technologies to back-end applied technologies. So you see here, we are able to provide all the solutions from chip design. We start with like SAL does, so we start with simulation, with calculation, and do the fabrication in semiconductors or on semiconductors, and then integration, integrating all the components on silicon or on board in order to get product at the end, right? So that industry partners can get from us all the solution they need. And you know that the semiconductor technologies, they are really complex, and no one actually is able to cover the whole value chain. So that you can find worldwide only some institutes or collaborations who is able to provide it, right? And sensors and actuators development has a really key role in for the German economy. You see here some data from drone development indicating the requirements from the market. You see here the market size from sensors and actuators up to 2023. So the numbers increasing, but you see here the price. The price of microsensors and microchip, see here, is decreasing. You need more sensors, you need better performance, but the price for the systems have to be cheaper. So the price pressure on SME, on industry is amazing. It's very high, so that the need to have such research to the ideas, I mean, how to get funding. You see here the funding schemes, or the kind of funding we are focusing on. Surely you want to have industry funding. So you want to have direct contracts with industry. So worldwide, you have Huawei, you have Facebook, you have Amazon here too, but we are not allowed to disclose their names here. But this is our first goal, to get money directly from industry. We want to do a transfer, so that we have a really good IP strategy here, so that before we do the research, we have to discuss about the ideas first with our lawyers in order to identify the potentials of the ideas. Maybe it is good for the transfer strategy at the end. So it's quite good in this term, in this case, to discuss internally with your lawyers first, legal department first, what is possible with the ideas you have, right? And projects. So in funding schemes, I'm going to show you the funding schemes you have in Germany. So that maybe it's the same structures you might have in your countries, in your areas. So this, I mean, this is quite could be similar. Countries like in North European Union or in North America, actually they have quite similar structures. Okay, I have actually I put the schemes into the two categories. The first one is industry funding, so that's how to get into contact with the companies, with industry partners, to convince them to invest into into your ideas, into your work. And the second one is the public funding, so from government, from local government, but also from NGOs, for example. In some cases, they are funding also research activities at the universities and research institutes. Right, you see here the programs or the funding schemes we have in Germany, but also in European Union. I put it into national funding schemes. We have here in Germany the DFG, so this is a German foundation research. The agency, you know that actually this the people here are funding the basic research, so the budget is not that high, but they are funding ideas in basic research like materials development. So really total crazy ideas they are funding. They are focusing on such ideas. And the second one is the the programs or schemes at ministries like education ministry, like transportation ministry, like economy ministries, for example. All they do have also funding scheme, right? They focusing on cutting edge, so new ideas, but not to blue sky idea, but the feasibility is already shown. So the technological readiness level of 2 or 3 you can start with, to get the technological readiness level of 4, 5. All right, so it's quite close to industry. That it on this TNR focusing the funding scheme as ministries. Okay, and then we have also local governments. They also have own funding schemes, and the name local government may give you feeling that too small funding schemes or too small funding programs, but it's not true. They have a really high budget for the research. If you can find the right consortium structure, you can give really high budget for your work. So up to 500 million euros actually have been such programs from local government like Berlin, like Bavaria. Bavaria is a really active, aggressive local government who puts a lot of money into the research because they are quite strong. They have BMW, they have Infineon, they have many big companies in Bavaria, so that they have also money to do that, right? And in Berlin, Brandenburg, we have also schemes like this, together with the investment bank of Berlin. They put a lot of money into that, and as a research institute together with industry, you need SMEs in such consortiums. But you get up to 400,000 euros for one project, right? So 3 or 4 years, so that's not small. So that actually you can get enough money for one project, right? But the local governments, they focus on application research, right? They request from you to show that the idea is very close to production. So that at the end, they want to have the technological readiness level of 6 or 7. So they want to see that in 3 years, in the next 3 years after ending the project, the companies must have products on the market, right? So it's quite strong. So that so we see that you need here for basic research really blue sky ideas, right? This is quite new, quite fast. The cutting edge is something in between, and application research, you need something really close to application, the industry. Right, and looking at the international, you have many programs, funding schemes from the EU, from the DARPA, for example. From the EU, this is really big budget, so 80 billion, right? So that really divided into 836 funding tenders. So you can find actually for every areas, research area, for all the all ideas, actually you find the suitable funding scheme here, right? And if you have really good idea, blue skies, you can submit in ERC. This is schemes for really new and for frontier research in medical areas, or in material research, or in artificial intelligence, for example. And the similar programs, Marie Skolodowskaya Curie funding scheme, they are actually have been designed for blue sky, really new and good ideas, right? And the normal funding schemes are designed for cutting edge. So you need here really good consortium between research and industry. Right, the codes are quite specific, but it's continuously in a year actually you find all the programs for all actually topics. Right. So here give some ideas how to get information and how to submit. It's very important for the all the programs. You need the contact points, the national contact points, the contact points at your universities, and support the structures. Actually, every city in the European Union, they do have such contact points, right? Technical University Berlin, the University of Applied Sciences, and here at the Fraunhofer Society, you have a business development team. So they are small teams between 10 and 20 people producing. They have a lot of information. So actually, don't be shy and really talk to them, because their job is to support you to submit the job proposal. The more proposals have been submitted, the better for them, because they can get more budget for their work and so on. And they have really experiences, and they, in some cases, really, for example, Max Planck Institute, some universities in the north, DTU, for example, they have a really good business development team. We have learned it in the last month. Actually, they have 3 people. Actually, if you have a good idea, Tang from SAN, you can confirm that. From DTU, they are really strong, the team, to support us to write the proposal.
Really perfect, really,
really good. And if not, they can provide you also the service, for example, to support you to write the proposal. Really good. And I have learned that the people in the contact points, they really friendly and support really very actively in all the ideas you have, right? From consortium, how to build a consortium, to look at the formalities, and to look at the time scale, and so on. Really, convenient to work with them. Okay, and the second point is that I mentioned before that in research, the value chain is we have really long and complex technologies, so that no one can be able to cover the whole position. So that you need really good network, you need the partners to provide the competencies you need in order to realize your ideas, right? So, and at conferences or there are some platforms, platform as U11 to find also platforms to find the partners, also national programs. They are supporting you to find such competencies you need, right? And you need time and effort to prepare one idea, right? So typically for one national program, you need 3 months. And for one EU program, so large scale, up to 8 million budget, for example, you need maybe 1 year, right? So take your time and really start with discussions with people in the consortium, with people you have found, to exchange and in order to finalize one idea how to. So we kind of research work you want to realize in one project, right? In some cases, it's really difficult and takes time and effort very high. But if you are in one project, in one consortium, you can continue to work with people and extend in other funding schemes. It's quite important. For the industry funding, actually, you find the agencies from the companies like Volkswagen, Bosch, and BASF. They are attending conferences, research, scientific conferences. They are looking for good ideas and funding directly, right? So that is the best way for them, for the companies, to get the research results faster. They don't want to join you in the public funding schemes, because they have to share, you have to disclose the reasons. But if you have a contract research with industry, actually they share the reasons directly with you. Okay, but they have enough money, companies like Bosch, so this doesn't. They do not care about what does discuss the research work, but at the end what they gain, right? So that actually at the beginning it's quite difficult to talk to them, but if they are convinced, you get the funding. It's quite easy, and you do not need to write a very long, very complex proposal like for the EU. You know that 150 pages is quite long and takes a lot of time, and you do not have time, right? So that if you find a company, this is quite convenient to do the research work and can continue actually for a very long time. We have many projects like this here in our institute. So since 20, 30 years, they are really they are supporting our work here in Berlin. Some companies, actually, I'm not allowed to disclose their name, but they are here. Even you know, companies from China, for example, actually are not allowed to do research work in European Union or in USA, but actually they are here. They are present in all funding schemes in here. Right. Okay. So that's some ideas about the funding, how to get the funding. So the private funding from companies and public funding. So if you have more you want to have more information, or if you have questions, you can ask it. If not, you can send me an email, or we can discuss about it later. I want to go over to the activities because I see that already 40 minutes after 2 p.m. I have to speed up.